All right. Hello, everyone. Welcome. First of all, I want to thank everyone for attending this talk. I will talk about building production grade harness using AWS Bedrock for my company, which is a health tech company. And thank you to AWS User Group Malaysia for inviting me. Um, yep. Before I start, I just want to do a room check. Raise up your hand if your company forbid any AI usage. No, right? Oh, okay, we got one. All right. So I heard some stories that company like really blocks the AI usage. And second thing, raise up your hand if your company only allows Copilot 365. Okay, we have also. Okay, raise up your hand if your company subscribe to any like LLM tools like Cursor, Claude, Code, or OpenAI or something. Okay, most of us here. Okay, I'm sure you guys use CLI day to day. If not, Codex app, Cloud Code on the web, Cloud Code on the terminal, or Cloud Web, right? Yeah, I think you guys already have some basic idea or some advanced idea. What is harness? Is uh, I would say trend right now. It's one of the top things, right? So when we first start, we have like prompt engineering, we have like context management, memory, people like building like some memory SAS and all that, and now we have harness, right? So I want to talk more. I want to talk a bit about my company. I think this is a PDF, yeah. So I work at Valiance Health. I also used to work at AWS as a solutions architect like 4 years ago, and also did a AWS user group talk as well 4 years ago, talking about IPFS, like some Web3 stuff before the bubble burst. So IPFS connected with CloudFront at the time, I think. Yep. And my company right now, what we are doing is basically when you go to private hospitals, right? You don't know how much you will be get charged. When you go into the doctor room, okay, we will diagnose you, and then you ask. Most of the time, at least in my situation, when I ask the doctor um, how much my bill will be, the doctor say around. They will give estimation, but it also will depends on your like condition, right? So that is what we are trying to solve. Basically, a pricing transparency for public, and we start with the hospitals first. So what we do, we go into their data and we do some like ETL processing, massage the data. And you know, uh, private hospital is a hospital, but it's still a business, right? They need to make money. At the same time, they don't want to harm their patient, right? To charge like very high. Of course, people will complain and all that. So we are trying to like optimize that part. So previously they don't know, they have like a very less idea about their data. So we go in, we help them to extract and clean up the data and show them, oh, this is where you need to optimize, this is where you are charging high, and maybe your like supply medicine is too high, you can like get more margin here, something like that. Yeah. So I joined this company like 1 year ago. So I worked part time before that, like 3 to 4 months. And when I joined, there were like a very basic AI like prompt engineering. When you talk about prompt engineering, you have like system prompt or like user prompt, and then you have like the pre-built prompt template, and then you just inject the data in the middle or somewhere in the blank space, right? So that is prompt engineering. So what we have back then is just that, and then my position there was like a full stack and infra. So yep, you can go to next slide. Um, when I joined, AI agent is like very early, but it doesn't make sense, right? It's just 1 year apart, but that time is very early. You can say very early, right? So I took the opportunity to really like study the business first, study what my company are doing, and see which part that I can automate with AI agent. And at that time, a very like popular agent use case is natural language to SQL query. That is very popular back then, and even Uber has a like a way of doing it. So it's like maybe we can start with that first because we have the data ready. We already extract the data, already clean up, and already follow like certain schema. All we need is data exploration, right? That is where the bottleneck is. Maybe AI can help a bit on the data exploration, like generate SQL for us, generate SQL for the user. For example, like top ten doctor based on the revenue like last month, something like that. So we at first we try to replicate the idea in our own environment. As I told you just now, we have like a simple LM usage, and we are using at that time very basic like chat completion. If you ever like learn OpenAI stuff, cloud stuff, the first one that you will stumble upon is chat completion, right? You pass system prompt, you pass prompt, and then it gives you result, and then you can like tweak the temperature and all that stuff, right? So we start with that, and then we are using Grok, the inference provider. Grok, they host like open source LLM model on their inference compute, and then they do like some kind of distillation, and then the token like become very fast. So yeah, mainly like prompt engineering. So phase zero, uh, all this stuff still like fresh and new. So there's no right way to achieve and doing stuff. We don't know. Even the when you scroll X, when you go like see read some paper, go and see like open source framework, everyone like trying to figure this thing out, like what we need to focus on right now, right? So the same situation as us, we which part we should focus first, maybe like build a framework or something, we don't know. So like I said just now, we start with SQL agent. And um, so the most important thing, building like LLM or harness or all of this stuff, right? You don't want to build it blindly. I mean, if for your own like learnings is fine, but if you have a startup business, you wanna work move backwards from your user, working backwards. Yeah, Amazon principle, working backwards. Work backwards from your user use case or what your user want to achieve, right? So most of the requests from our user is basically when they go in the dashboard, they want everything to be like automated. They want to be served like a full complete report, and AI can do that for them. So they don't need to work anymore. So, but it doesn't make sense, you know. I mean, on our side, do you wanna your job to get replaced by AI or what? So yeah, it's kind of impossible. Like, first of all, of course, the data, right? So and another thing I learned from these hospitals, right? They used to spend a lot of time like making sense of the cost, because it's normal when you go to hospital. Of course, you have insurance, right? So hospitals, they need to claim to insurance for their money. So the insurance will deduct from our subscription. So that's how it works. But most of the time, when they want to claim the amount, certain amount from the insurance will query them back. Why this is so expensive? This doesn't make sense. So they really like spend maybe quarterly, like making sense of the cost, and really look what is happening. Is why the length of stay charge is very high. Did this patient like eat a lot or something like that? I don't know. Yeah. So there's a lot of like gray area, and they also don't know what to do with their data. Yeah. So these are the use cases. So, being me, I am a library driven guy, library driven development. So, I always, if I want to build something new, I always try to look for like framework or library out there. So, I do framework exploration first at first. This is our early phase on building proper agent stuff, right? So what I want for my framework is human in the loop, uh, first class support for checkpointing, meaning when you interrupt the agent midway, you can like continue with the existing context that agent and user has passed to the conversation, right? So can continue session and built-in database for conversation and token. I mean, at that time, LLM are still dumb. To be honest, I was using like Claude Sonnet 3.5. Like it cannot code very well, so that's why I was thinking, just use like out of box stuff. I don't want to like build my own schema and capture my own token and all that. And another thing is I want to do like agent to agent collaboration. I will talk more about agent to agent collaboration after this, and also hand-off concept. I will talk more about hand-off concept also after this. So these are the goals that I want for the framework to have. I have a lot of demand. So yeah, I will talk about hand-off concept first. So hand-off concept is very popular. Like it is first started when I saw from Autogen framework from Microsoft. So they explain a little bit about this hand-off concept where when the agent are working on one stuff, and then the context like too much is hitting the context line already, it will hand off the context to another agent. So that is my understanding at that time. So I was like, maybe I want to design some workflow or AI agent workflow around this concept, right? This is very like a very popular concept. This is way before the 1 million context was introduced to Sonnet and also OpenAI. Yeah. So the idea is one agent do the query, pass the to data analyst. I will show more on this. So I learned this from Workera founder. He was teaching, he was doing lecture at Stanford, I think. So I was looking at the lecture, is around 1 hour. I will share the link on my LinkedIn later. Yeah. So there's a multiple way for you to like build like multi-agent collaboration or workflow, flat, hierarchical, sequential, parallel. So this is all, you want to build this around your use case, right? Yeah, so for our use case, my way of development, I will always start simple first. I start with like flat, like straightforward start to end and just like provide result to the user. So, okay, this is the first framework that we use, Pydantic AI. Yep. Some of the point that I can say about like Pydantic AI, the docs are messy, and a lot of their stuff are still in beta version. So our goal is to like get this to production as quick as possible. So we don't want to have like beta stuff on production, right? So and also they coming from the Pydantic, the validation library. So they are selling a lot of like Pydantic stuff and combined with Pydantic AI. For example, if you want to call tools, you want to validate the tool result, something like that. Yeah. I mean, I'm 50-50 on that, but yeah, also want freedom, right? Because LLM is very undeterministic. Pydantic is also lack of session management and session continuation. I want that. The second framework I explore is Crew AI. It's very slow. I try it for multi-agent collaboration. It's not usable at all. Even my experience already bad. Imagine if I deploy it to our customer, right? So I don't want this. And major turn off that it doesn't have streaming support. Bro, if you want a long running start, you of course you want to see like stream result. At least for you, when you use Cloud Code and all that, you want to stream, you want to see the progress, right? So they don't have that. But Crew AI is very good for multi-agent collaboration. The framework is very verbose and deterministic. The way that they design the framework is very like developer friendly. Next, Autogen. When I heard of Microsoft, I already like I want to stay away from this. Of course, they want to lock you inside their environment, right? They want to force you to use OpenAI. because at that time cloud is still not in Microsoft environment. So now they have, right? Cloud is inside Microsoft right now. Yeah. So they don't support like Bedrock or Cloud, of course. And LangChain is legend. I would say legend in this like LLM world. It is one of the first framework for LLM. I think I learned this like uh, GPT-3. I already learned about LangChain. It's too simple and straightforward. It doesn't cover like most of the use cases that I want, the goals that I want. And oh, I didn't finish my point there. Like it's mostly covering like straightforward stuff, check completion basically. Yeah. So the winner is LangGraph. LangGraph is like all in one. They even guide you to do production environment. They also have support for Django. So Django, we are using Django. For Django migration, they already like scaffold table for you, interrupt, human in the loop, and all that. And also a big win for us is able to integrate with Bedrock. So yeah, phase 2, integration begins. A lot of experiment with LangGraph. So LangGraph, like a lot of people say the learning curve is quite steep because the way LangGraph work is like very big decision graph, and you need to like really put the nodes meaning the agent, properly. Like you need to condition it. You need to like build your router properly. There's a lot of this is really not a one-person work, so that's why it took us a lot of time like building this. It's hard as well because I would say this framework is battery included, but you don't want everything in one go, right? But somehow they force you to implement everything in one go, like all the HIT, human in the loop, all that. But what I like about LangGraph is the state management. So when you want to do handoff, passing context to another agent, they already have like built-in state in the framework. So you just park everything in that state, and all of the agent inside your workflow will know what is happening. So this is our first design of agent workflow. We have like first we have router um, to route user attention to specific workflow, and we have data scientist, data analyst, SQL generator, and result analyzer. So the idea behind this is that I don't want one agent to have like context route very fast. So I want them to share the context evenly so that they can produce a good output. And also, I want to find out what special about LangGraph is that you can mix and match the model. You can, for example, like non-critical stuff. For me, like router, straightforward, right? User say, I want to do this. Okay, I route here. So I just use Nova. It's cheap, it's fast, and it's non-critical. For me, router is non-critical. It's like the system prompt is very definitive. So for like critical stuff, generating query, exploring the schema, executing the SQL, and analyzing the result, I use more clever model, which is Sonnet. So funny thing about this, we use we don't use what's Opus. We use Sonnet because that time I want to try something out, so I just default to Sonnet. And of course, another reason is because it's cheap. And dude, the result produced by Sonnet is very good. We don't even change it until now. We are still in Sonnet until now. We don't even change it to Opus because the result they produce very good. The context, how manage context, how Sonnet do like cool tool calling is perfect. So we just like, I mean, it's cheap and then it's good. So we just stay Sonnet until now from the experiment. Yeah. So yeah, this is the idea, like different node, different model. Yeah, router, it all start with router. Where so your router can get like large very fast, so you need to optimize the system prompt of your router. So once you have a very good router, you can do like almost everything in one place. You can like do like AI agent support stuff, not really like related to your BAU stuff, right? You can like do like chart generator, generative UI, right? The one that popular currently. And yep. So this is our first integrated prototype. If you can see, the date is it's actually not long ago, August last year, 1st of August last year. Yeah, so this is the first version. Just ask tests and then it can answer with streaming as well. Also, Bedrock provide the thinking as well. That is good for troubleshooting, for eval, and all that. So after we finish our first implementation of agent workflow, you know what? Cloud Code become more powerful. Sonnet Opus 4.5 drop, and people are moving towards agent and sub-agent concept. This is just to show you how fast this scene are moving, right? So we just finished and deployed to production, and then suddenly we have all skills.md, agents.md, CLI, MCP, and a lot of that stuff. And now people talking about harness, sandbox, and all that. So what we did, we follow what people are doing. We ride the same wave. So we are pivoting our agent implementation now. So harness become the buzzword now, right? So we have like sandbox, skill file system. With people like giving a very big autonomy to their agent currently. So yeah, we are moving. We are moving towards that. But then if you look back on the trend, right? Most of the power user are technical person like us, like developers, technical, right? So that's why um, uh, mm, they are focusing more on the coding stuff like cursor, cloud code. They're improving on that side more. They didn't improve on the uh, like normie side more, right? So for us like tech savvy people, we access terminal day to day. The agent lives in the terminal, and they have access to our contacts, all of our file system. It's nice, but what we happen to non-tech people that doesn't even know how to open their terminal. So we were thinking like our application, we need to implement this fast, but how to bring all this harness, because most of the harness are built for coders for like running the stuff in the terminal. So how do we bring this into our app? So of course we're trying to find a framework. So we saw one framework called Deep Agent, of framework by LangChain company also. So we tried that, and this is what the first step into building harness. So basically, the idea of harness is like giving your agent more autonomy. So what we are basically doing before is restricting the agent, like just follow this workflow. Don't go like don't be wild. Follow this workflow and produce this result. But the idea of harness is giving your agent the most autonomy as possible, and don't like set like some certain workflow for it. So I was like, okay, maybe we can start with sandbox first. So sandbox is a like fire and forget stuff, right? Agent can run. You can like put anything like CSV, 1 million row of CSV inside the sandbox, and you ask the agent, oh, please run some kind of like data anything inside here, and it will like produce like Jupyter Notebook code stuff like pandas and all that, and do the expression inside the sandbox. So interestingly, the agent like behave much more better compared to our previous workflow where we restrict the agent. So we just give it the sandbox. Here your sandbox, do your stuff. The exploration that they did on the data is much better than compared to what we have before. So at that time also RLM dropped. So RLM is basically recursive language model. The idea of RLM is you put like a very large context in one variable, and what the agent will do is it will iterate through that. You can also set the max iteration, and of course you can pass system prompt as well. So we double down on sandbox. So the idea, like I said, you can dump like throw CSV like 100,000 lines. Hey, analyze this. I was very skeptical at first. This will not work. How can the agent knows things about medical and all that, right? But yeah, the result is insane. I can show you later. So we immediately replace our existing workflow with first harness implementation, which is giving sandbox access to the agent. So we use Amazon Code Interpreter, but the only cons of Code Interpreter is it only exists in US West 2, which is first latency, and then outside of Malaysia region. So it's too bad being episode is 5, right? We don't like receive, we don't get the latest features early. So yeah. Um, so we scrap all our implementation before, we remove certain nodes and give the sandbox. First, we still have the data analyst to execute the SQL. And from the result, we dump that into sandbox and then pass the result to the result analyzer and produce the output. Yeah. So better and extra analyze step. So where for the previous workflow, the result the agent doing result analysis is very it feels restrictive. It do like straightforward analyze. So when we give sandbox, it does more than that, and it has like access to pandas, numpy, and other library. I saw the agent like use all of that to explore the data, and most importantly, we save more token because the agent, what they care about is just the end result, right? So all the code and all that, they didn't really count. They already have like a specific code that they want to execute. So the token will not like run very far. And then the result, when you pass the result, when you pass the CSV into the sandbox, doesn't include in the token count. The CSV is just they iterate the CSV. They use like df.hat, like get the first 5 row and all that, and do the data exploration. Yep. So this is our harness with sandbox. We have like, if I can zoom in here, yeah. We still have the workflow, but then we throw in the sandbox in the middle, and it execute all the code here. Yep. So we call it advanced computer sandbox code. Yeah, this is the sandbox. Okay, so it knows what to analyze. My prompt here is top 2 doctor, like very simple prompt, but the analyze very like thoroughly. Yep. So this is the result. It's quite good. This is just a sample data, so it gives the breakdown of the 2 doctor. The doctor did like 3 case count, average cost per case, total cost. Like it even compare, and yeah, of course, agent like produce markdown very well. So yeah, I like that so much. How do I go back? Okay, so the real work is actually context. So the most important part of building agent is context. You give the agent the right context, it will perform well. So to build like a good context, you must have a good data. Everything goes down into data. Your data need to be like ready for agent to use. For example, we have like specific table that we put embeddings inside there, so that agent can query like using embedded query. So we have like ranking as well, you know that, and yeah. So another breakthrough that we saw before is building our own like ontology resolver. As you know, Palantir, the company where you can track people, right? So we are building the same thing where the agent can reverse the prompt and the question that user asks. For example, give me more info about paracetamol in certain hospital. It can reverse the paracetamol until the first principle. Paracetamol is built on what is the code for paracetamol. And as I said, you need to get your database ready for this. So yeah, it can do like data exploration, like graph traversal and all that. So we currently also like working on improving the ontology resolver. And yeah, I want to talk about, we are coming to an end to this talk. So we want to talk about our little bit of our tech stack. Of course, AI we only use Amazon Bedrock. We don't use Agent Core. We don't use Agent Strands. We don't use all the embedding. Also, we don't use Titan, right? They call the embedding stuff in AWS. So we only use Amazon Bedrock with Sonnet 4.5. And for sandbox, we use the code interpreter in US West 2. And for database, we have PostgreSQL with pgvector using multiple embedding tables. For the embedding, we use BM25, if you know the library, the model. And backend, our backend is still using Django. Front end React with Shadcn UI, everything on AWS. So we deploy our backend on ECS. Fargate, yeah. So learnings, like as time goes by, when I build this stuff, right? At first, I was looking back on the journey. I was too focused on building the memory management and the interruption and human in the loop. I was too focused on that. I was like, how to interrupt this agent, how to continue back, how to manage the conversation. But then when I look back on the usage, actually our user, how the pattern, how they use the agent, right? They go inside and ask something, and then they didn't follow up at all. So it's like such a waste of my time, like thinking how to like properly manage contact for follow up and all that. So it's like I don't want to focus on that anymore. I just focus on building like good tools and good harness. Yeah. Most of our users don't need like a long running conversation. They are basic user, right? For us, like power user, we need to manage our context well. For example, we are doing coding, we are like doing like spec driven development and all that. We need a proper way that suits our workflow. But then for basic user, they know that they just use it to ask one question and then they go home. So yeah. And then the next day they start with new session. So yeah. What's next for us? We are currently working on minimal harness framework. So we already scrap LangGraph. We built our own harness framework for more control, and we are following the global standard what people are using right now, like skills, the MD, helper, CLI, and all that. And for our new harness, we also like build our own like sandbox runtime. We're just using Docker. We don't use like code interpreter anymore, self-host. This is part of our compliance also. We are trying to get HIPAA and SOC 2 compliance. And the idea of like building minimal harness is that we can bring this harness and fit into any model. Even ilmu, we are trying to fit it into ilmu. We have ilmu, right, in Malaysia. If we want to move to OpenAI, if our credit is running out in AWS, we want to move somewhere, we can bring this harness there, and it will work the same way as how when it using cloud. So that's the idea. And the idea of this harness also, we want to make it extensible while keeping it minimal. So for LangGraph, you want to extend the workflow, you need to add like one new node. One new node is very, very expensive, I would say, because you need to manage all the harness around it, right? But if you are building like your own harness, for now, for our case, we only need to add like new skills. If you want to achieve new things, like for example, generative UI, we just add new skills. And then if user want the agent to generate PDF, we just add new skills. Very minimal, it's not really costly. So have you seen the other day when the cloud code repository and code got leaked? You know, right? That time. So we saw. I managed to see how they built their like code and all that. It's very basic, man. We can copy this, and even people say open code harness are better than cloud code. So yeah, it's like AI are getting powerful day to day, day by day, and I think we just like fork any open harness, open source harness, and implement it in our company. Yeah. So this is also the next thing that we are building, super ontology resolver, more than vector search, more than embeddings. Basically, in medical, we have a lot of coding. We have like ICD and all that. If any of you doctor here, you know. So the core of our agent is the ontology resolver. The agent need to know what, for example, procedure like colonoscopy, something like that. They have a lot like coding, and when you go into operation for colonoscopy, the patient can have like multiple condition. Like if the colonoscopy is intestine, right? So the patient might have like diabetes and all the conditions, so the code will become different. So all these existing model are not trained for that. So that's why we are building like ontology resolver to fit a good context to the agent. Yeah. So this is our sandbox runtime. We are planning to open source this. I think it's very minimal. You can be your own. So it's just an agent and Docker runtime, Docker built in with all the libraries, pandas and all that, and it just can do like code execution. Code execution is quite scary, you know. It's very like you can expose to a lot of threat. So that's why we are, if you want to open source this, we are going to put some disclaimer. You need to host this in a private VPC or what. So we are hosting this in private VPC. Only our ACS can access it. So yeah, still all the package inside there. You know, nowadays we have like supply chain attack, Shai Hulud and all that. So it's very dangerous. So yeah, this thing we need to really build it properly. Yep, I think yeah, that's all from me. Thank you very much. Open for question. Yeah. Please. My,
Hey, Farhan,
yeah.
Ajri here. Question, in one of your slides, you mentioned that using sandbox reduce token usage. How does that work?
Um. So where for LangGraph, right? When we are getting result from the SQL execution, we cannot get like we tested, we cannot like have more than 100 rows of result. If not, the context will rot like very fast. So we figured that out very quick. So one way we handle that is we do a group by. So any SQL that agent generate, we tell the agent please use group by. Don't like if the result is like 100 rows plus, please don't do that. So it's very restrictive. So of course the context will rot fast. So how Sandbox actually reduce the token usage and reduce the context length is that we pass the CSV, the agent only see the CSV. The agent doesn't see the result. So what the agent did inside the sandbox is they explore the CSV without really taking much token. So like I said just now, they only like see the first five rows of the CSV. If we have like 1,000, right? And they only see the pattern and they already know what column to explore and all that. So that save really much token. If we like pass like 100 row, yeah, is compared to our previous way, yeah, that's how we save token. Yep.
In other words, you reduce the amount of processing directly the results from
Yeah,
SQL.
yeah, because when using LangGraph, you pass the SQL result to the state, LangGraph state. So when using sandbox, you actually pass the result using CSV inside the sandbox. Yeah. So we don't ask we ask the agent please do not like query render all the result from the CSV. Just explore the column, the first five rows, and it already know what to do. Yeah.
Nice.
Yep.
Thank you.
Yep. Anyone else?
Thank you. Hi, Farhan.
Yo.
Uh, my question actually is about the result of your agents. How are you able to test the quality of the results? Is there some sort of manual testing, or did you create your own process for that?
Yeah, good question. As you can see in my talk today, I don't talk much about evaluation. Doing eval is very hard. I mean the proper eval. You need to have a golden data set. You need to like have a dedicated AI researcher inside your company to do eval. So what we did was we store everything. We store the tool call. We store the result from the AI. And so being startup, right? How I validate the result is good. I just ask my CEO and CTO. They are both are doctor. So is this result okay? So they say okay, okay. And then we test in production a lot. So when we go to our client place, to the hospital, we ask them to like prompt in front of us, and we ask them, is the result good? Yeah, it's good enough. So it's like, okay, it's good. And we maintain, if the result is good, we maintain that. So if you want to tweak something, we only work on the like system prompt, the user, the prompt engineering around it, the harness, and all that. So yeah, that's how we improve quality and monitor the quality of the result. Yeah, a lot of time I can say uh, the result are okay lah. Sometimes the agent got about a little bit like so the LangGraph, the workflow that we build. For example, if the SQL fail, right, some function of the SQL doesn't exist in Postgres. That is very popular error that we face. So what we do a retry loop. I didn't talk about this just now. So if the SQL fail, it will retry again with a new SQL, like fixing the SQL that failed based on the error. So we have that inside our workflow. So even with the new harness, we also have that. Like you retry this. I think I have the screenshot. I will show later. So yeah, that's how we maintain the quality of the result. And from the fail SQL or fail any fail result to calling and all that, we store everything in our back office in our DB. So at the end of the day, after testing, I just do like eyeballing. Yeah, right now everything is eyeballing manual. We are currently also building LLM as judge. So eyeballing sometimes like hard, right? So I just press a button and AI will tell me, oh, the quality is bad. This is where you did wrong. The tool, maybe some of the tool are not correct. Yeah, we are also building that right now. Yep.
Hey, anyone else would like to ask?
Anyone else? One. Yeah.
Hi, Van.
Yes.
I have a question. So for the ontology resolver, right? Is it similar to RAG?
It's it's RAG on steroid. So basically RAG, when you it's a like similarity search, right? When you search like for example paracetamol, and it will give you all the paracetamol inside your DB, and you can ask it to give you like top K, like top five. But for ontology, it's RAG and combination with graph traversal. When after the RAG already get the result and do ranking, it will traverse from the table that we have, which is what we call that reference or pivot table, to get the code, to get more context from all around our DB. Basically, that is ontology. Is a I would say RAG on steroid, or yeah, like more step from RAG. Yeah.
All right, thank you.
Thank you. Can be your own. I think we all can start with coding stuff. Like you can see how Cursor does it. They use like turbo buffer and how they feed context to the agent, right? Yeah. Nowadays, I think it's very easy. You don't need to think about the context that much because we have like large context window now. All you need to think about is about the harness. Yeah. Yep.
Sorry. Just curious, one of the slide you talk about tokens. Very briefly, you mentioned that certain things does not consume a lot of tokens and how you maximize that. Maybe you can explain a bit more about that? And also, I saw one slide you mentioned Grok. That's the only time that I mean, it's not that common, right? People always talk about Codex versus cloud. Yeah, so just one curious to know.
I'll answer on the Grok thing, Grok stuff first. So, do you know any inference provider like Cerebras, any inference provider? So basically, Grok is an inference provider. They host open source model for you. For example, we have GPT OSS. So what Grok, this company does, it takes the open source model and do some distillation. So normal like token speed, I don't know what's the normal token speed, but if it's hosted in Grok inference, become faster because they did something with the model. So yeah, that is Grok. Yeah. Inference provider. Yeah. So about the token, which slide again? What's the question?
Talking about like the agent using NumPy and all that.
Oh, the sandbox. Yeah. That's what I explained to Azri just now. So when we use before we use sandbox, right? Um, you saw the SQL execution part just now? Yeah. So before we are using sandbox, when the SQL execution, before SQL execution, we ask the agent to generate the query, right? So uh, when the agent generate the query, sometimes the query get more than 100 rows of result. So that will consume first the context window, and second, of course, the token, right? Because you are passing 100 rows to the agent to process. It will take a lot of context and token. So how we fix that is we use sandbox. So we don't pass the result anymore. We pass the CSV to the agent. So after SQL execution, we found one CSV file, and then we pass to the agent, and we ask the agent, don't get all the result from the CSV, just get the first five and do your thing. Like count your average, like just don't get all, like just don't list all. Like count the average, count the like top five, something like that. Yeah, that saves us a lot more token. Yeah. Yep. Yeah.
First thing, I'm sorry, I was going for praise just now during your talk.
Okay.
Yeah. First thing is that I want to know, is your ontology live ontology or pre-process?
Live ontology.
Live
Yeah,
ontology.
we do it on the fly.
Okay,
Yeah.
then how do you manage the latency?
Manage the latency. Okay, so we do partitioning in our DB. So there's a lot of like code, right? Millions of them. So we do like partitioning in our DB so that the query for ontology become faster. Yeah. Yeah, partitioning. Yeah. Yep.
That's all. Actually.
Okay. Does that answer your question?
Yeah.
Yeah. That's what we did. That's what we did.
The latency is always an issue.
Yeah. I know. That's why
Especially big data.
yeah. Is the latency between your backend to DB or latency inside your DB?
Latency inside DB.
Inside DB, yeah. Partitioning is what we did. Yeah, maybe can optimize more, I think. Yeah. Yeah. Thank you. We also have embeddings inside yours. That's also make it faster.
Process.
Yeah, we do like post processing partitioning also. Yeah, for the embedding we post process. Yeah, we have pipeline for that. Yeah, so we scrap the code from somewhere and then we embed it. We use open source model, BM25, BM25. Yeah, and we have like embedded columns inside there. And you need to have like PG vector extension enabled if you are using Postgres. So I also used to use ChromaDB, SQLite. Yeah, but I like Postgres better because you can put the embedded data in the same row as your real data. So yeah, it's much better to troubleshoot. Yeah. Okay. No problem. All right.
All right. Thank you very much.
Thank
That's
you,
very
guys.
interesting.
Follow me on LinkedIn and subscribe to my YouTube.